So, what is a point source? If we look at how this term is used in lighting, we may conclude that the correct answer is that it depends. There are two types of definitions, and to make things even more confusing, very often the term point source is used without clearly referring to one definition or the other. And this leads to endless debates about whether LEDs are point sources or not. And so here I'm going to describe these two definitions and offer in the end some ways to disambiguate to avoid these debates. So the first type of definition is what we see in physics and mathematics textbooks, and it says that a point source has no spatial extent, so it is an ideal point source. In real life, obviously, there are no such objects with no spatial extent. And the second part of the definition is that light, or whatever it's producing, is leaving this source isotropically, so evenly in all directions in space. The wavefronts are spheres around the source. And as we see in this graph, a real source has a spatial extent, but if the source itself is a sphere, for example, then it can be perfectly modeled with this ideal point source. At least the light which leaves the source can be perfectly modeled. And therefore, there's oftentimes a practical advice added to this definition regarding when such a point source model is meaningful to be used, and it says that it is meaningful when the resolving power of the imaging instrument that we have is smaller than the source's angular size. And so this sentence is, strictly speaking, not part of the definition, but it's an advice regarding when to use the definition. And this is where the confusion starts, because in some circles this sentence itself is treated as the definition of a point source, and this is where the second type of definition comes from, oftentimes used in lighting, which says that the only thing that defines a point source is that the angular size has to be smaller than a given threshold. And this threshold is based on the resolution of our imaging system. So if we know that, we know the threshold, and then we also have to know the distance from the source and the size of the source. And that gives the angular size based on which we can decide whether it's a point source or not. These numbers are from this 2013 ICNIRP document. There will be all references in the video description, which clearly defines a point source according to this second type by saying a source is considered a point source if the angular substance is less than or equal to 1.5 milliradians. Now, there are problems with this number itself too. As they say, this corresponds to a retinal spot size of 25 micrometers. That would cover in the fovea about a dozen cone receptors, so even the passive resolution of the eye is about an order of magnitude greater than what they state here, but in reality, with eye movements and all dynamic processes, the maximum resolution of the eye can be up to 80 times greater than this. There are all kinds of other problems with this document too. I have talked about some of them in another video, but the second type of definition is clearly given here, and it is very often referenced. And as we see, it says nothing about the light intensity distribution of the source. And so this is what leads to the confusion, because the first definition does very clearly state what the light intensity distribution has to be. It has to be isotropic with an ideal point source. But an LED as a Lambertian source produces a very different intensity distribution, which is greatest along the surface normal of the source and smaller at any other angle from it. So generally it is Lambertian. Some LEDs are more like that, some have an even more elongated shape of the light intensity distribution that they produce. And in real life measurements, we indeed see that some LEDs are very closely matching the Lambertian distribution. Some not so closely, may even be asymmetrical or uneven or more elongated in some way. And therefore, it is understandable that the second type of definition is used often in lighting. For example, in this SPIE document, where they start with the second definition so that it's a so small solid angle and therefore a point source model can be used. But then they also add an assumption about the light intensity distribution. So the directional distribution of light from these simple models is usually assumed to be isotropic or Lambertian. So in this way, we can use the second type of definition of a point source for an LED by also saying that we assume a Lambertian light intensity distribution. This is precise, but it's more verbose, and the confusion starts with only saying point source without clearly saying according to what. And this is what we very often, even more often, see in lighting. For instance, here, just a point source, for example, LED. What do they mean? Also here, incandescent halogen and LED lamps are typically point sources. This is very confusing, and there is no clear definition given. So, to solve this problem, in my mind, it would be much clearer if only the first type of definition would be used, because it is older, it is more precise, and it incorporates more into it. So it also refers to the light intensity distribution. And then whenever this definition cannot be used, for instance with LEDs, then we could use a different term. For the size of the source, we could just say a point-sized light source, and then it would be clear what is meant by, which is here I call the second type of definition. And then the light intensity distribution would also have to be specified. Now, obviously, I'm not going to be able to change the current practice. So if point source is used today according to both the first and the second type of definition, then at the very least, one should always disambiguate which one is used to avoid all these pointless and endless debates.